We're going to get started here. Today's talk is about hardening Windows applications, and this is Ollie B. He's going to give you a little bit of background on where he's from.
Afternoon, everyone. Glad to see so many people showed up. I know there are lots of good talks going on at this time slot, so I'm not surprised. I wouldn't be here either. Anyway, I have to be here, so I'd just do a quick introduction of myself first. My name is Olle, or you can call me Ollie if that's easier to pronounce. I'm from Sweden. And today I'm here representing the Toolcrypt group, which is basically a small group of researchers from Scandinavian countries mostly. We do basically defensive research in OS technologies and network security. And we publish some stuff on our website, which is in the slides, www.toolcrypt.org. I have to pimp that out. By day, I work for the Swedish government, the Swedish Armed Forces, also doing defensive system security. So what's this talk all about? Well, the agenda for today is I'm going to give you a brief introduction for those of you who aren't really up to speed on the Windows security model and the how security works in Windows. And then we're going to go through some interesting features of Windows that can be used to enhance the security of your applications. And we're going to finish off with a section on strategies for making more secure Windows applications by employing some of these technologies that we've talked about. So let's just breeze into this. Before I actually do, are there any developers here today? Oh, there are. Interesting. It's always nice to hear to get developers coming to security conferences. Right. So the Windows security model is there's the central part of the Windows security model is built on security descriptors, which are basically I won't get ahead of myself. Before we go to security descriptors, who hasn't heard of a SID? Everybody knows what a SID is, right? So I'll skip through this slide because it's just there if nobody knew what it was. A security descriptor is basically what a label you put on a system resource, an operating system resource, that controls the security access to that resource. So in the security descriptor data structure, you'll have some fields like the owner of the object, the group of the object, basically just used for POSIX because in Unix systems we have an owner and a group that we can set permissions for, but not really used in the Windows world. And there are some access control lists. There's a discretionary access control list, which is used to grant or deny access to the system resource. And there's the system access control list, which is used for, among other things, auditing. We'll get to that later. Oops. So access control lists basically built up of, it's just a list of access control entries. And access control entries are of a certain type. So you have one type, for example, controlling auditing of access to system resources, and that's only used in the system access control list, or the SACL. I'll keep referring to these as DACL and SACL, so it's much easier to say. We have some flags in each access control entry, flags controlling, for example, inheritance. For example, in a file system, you can set a DACL on a directory that will propagate through to subdirectories and things like that. And an access mask. And the access mask is basically what you match the access that's being asked from a system user to a specific resource to the access control list that grants the user the access. And I'll explain a little bit more about that. And of course there's a SID that identifies the trustee or the user that's granted this access. So the access mask can, for example, be read access only, and that would set a number of bits in this bit field. Now, resources in Windows are most of the time, they're represented by objects, so-called objects in the kernel. This has nothing to do with object-oriented programming or anything like that. They're just called objects. And these live in the kernel, so they're not accessible to user-land applications, of course, because they could be manipulated. A kernel object, basically, I'm going to skip through this because I think it's mostly obvious to the people who actually are here today. Most of them contain a security descriptor that controls the access to the actual system resource represented by this object. So how do the applications then get access to these system resources? Well, basically they ask for access to a named object, for example, or some other object that they want access to, and a kernel function called seAccessCheck compares the DACL in the security descriptor line by line or access control entry by access control entry from the start to the from the top to the bottom of the list against a access token that the current that the calling thread or process is running under. So, for example, if I have a process running as a standard user on my desktop, it would compare that the SID of that user, for example, to each access control list entry in turn, and once it finds a SID that matches, it would compare the access mask in the access control entry to the access that's being asked to be granted, and if those match, rather if the requested access is a subset of the access in the access mask specified in the access control list, access would be granted. Now there are other access control entries, of course, of other types. I said there's, for example, a access control entry type to deny access as well as grant access, and that's pretty important to the security model. Now, these objects are basically granted access to, and a opaque value called a handle is returned to the user and the user land. And basically, for each process, there's in the kernel a table of system resources that are that have been granted access to, that have been issued a handle to some thread in this particular process. And basically, that's a lookup table where this handle is basically an index into the lookup table, which gives you a pointer to the actual kernel object. And since the the table lives in kernel land, it's not susceptible to manipulation by user land processes. So that's how the security works. So the important thing to remember about this is once you get granted access to a resource, once some piece of code in a process gets granted access to a system resource, that gets added to the handle table of this process, and from then on until the handle is closed and it gets taken off the table, every code in that process, all running code in that process, has access to that particular resource. Now, tokens. I mentioned an access token before. And an access token is basically the data structure that contains all the security context information that's relevant to a particular thread or process. So when we say that a process is running as a specific user, what we really mean is that there's a specific SID in the primary token of that process. So a token looks something like that. There's loads of fields in there. I've tried to list some of the relevant ones. One is a list of privileges, and we'll get into what privileges are in a bit. And there's a list of users and groups. So basically, if I'm logged in as a standard user, that list would contain my unique user identity in the form of a SID, and it would probably contain the SID of the standard users group or the domain users group or something like that. And there's also information about the what's called an impersonation level. So I said before that a process gets assigned a token, or a process has a primary token. When a process gets started, it gets assigned by the system a primary token, and this is the access token that basically controls or controls access to system resources, except in the case when a thread in the process has called something called an impersonation or a delegation. And what that means is that you can actually take a new token containing some completely different information and temporarily make it the access token for that particular thread, which is very important. For example, if you're writing server software and you have users connect, you'd really like to have access control being taken care of by the system and not being having to compare or keep track of access to, for example, all files in a file directory or directory structure. So you'd much rather offload that to Windows. So what you could do then is, once a user has authenticated himself, you impersonate that user, which basically assigns a temporary impersonation level token to that specific thread, and every access control request that's made by that thread will then be compared to the information within that impersonation token. So, what are privileges? Well, privileges are basically privileges that you can assign to either a user or a group in the system, and they control access to certain functions within the system, certain, you could call it stuff like debugging the processes or getting access to the memory space of processes of another user, for example, is something that you don't want anybody to do, so that's granted by a specific privilege. And there's a lot of these that can't be controlled by regular DACLs in a security descriptor are controlled by privileges. So these privileges are stored in a list in the token, as I said, and by default they are disabled. So before a privilege gets used, you actually have to go in and manipulate the token to enable the privilege before it can be used. It's kind of a safeguard to make sure that you want to use that privilege at the specific time that you're using it in your code. So it isn't used, so it doesn't have an unwanted side effect should your code be run by a user that has specific privilege. Okay, so hopefully I'm very jet lagged. Hopefully my ramblings on security model have been somewhat clear to you, or if you already knew it, I'm happy for you. So we'll move on to the actual meat of the talk, which is going through some security-related features in Windows. And we're going to try to discuss how these can be used by third-party application developers to increase the bar against attack. So first of all, there's this lovely feature called a restricted token that's been in the Windows OS since 2000, since the Windows 2000 release. And basically what you can do is you can remove certain privileges or remove certain SIDs from the list of users and groups within a certain token. And that token can then be used to either as an impersonation token, or more interestingly, it can be used to create a new process using this token. And this is really interesting if